So this video is now going to be sketching a graph while it's in either standard form or factorized form. The previous video looked at sketching while it was in turning point form. So the first thing we need to make sure we do is ensure the equation is in standard or factorized form. And an example of this, so for question 1, an example of question 1 is x plus 2 x minus 1. That's in factorized form. Or it's in standard form. In standard form is y equals, for example, 3x squared plus 2x plus 1. Okay, so that's an example of standard form and factorized form. So the next thing is the coefficient of the x squared negative or positive? So this is where you need to make sure it's in standard form. So sometimes it might not just be so evident. So if we say, for example, we have x minus 2 in brackets 3 minus x, we need to expand this first to determine is it going to be positive or negative. I can tell you already it's going to be negative, but let's just show this. So this becomes 3. If we use FOIL, 3x minus 6 minus x squared plus 2x. And so you can see here the coefficient of the x squared term is negative. So therefore that will be a negative graph. So again, the same rules apply. Negative is a negative parabola, positive parabola. Now the next one is find the x-intercepts, and the way we find the x-intercepts is by equating y equals 0. And what we need to keep in mind here is that this step we will probably need to implement the null factor law. And so hopefully you've watched the video on that. With step 4, we've got find the turning point of the graph. So if we want to find the turning point of the graph, we need to use this particular formula right here, minus b over 2a. Because do keep in mind that if we have a parabola, and let's just say we've got one intercept right here and another intercept right here, we still need to know where that dip is going to be. We need to know whether or not that dip's going to be there, or the dip's going to be here, or even there. So we know how to actually curve the graph, or if we didn't have an accurate turning point, the graph may as well just have looked like this if we didn't have a turning point. So it's essential in this case. Everything else falls into what we usually have with our sketching graphs. So let's have a look at the example now. Ensure the equation is in factorized form or standard form. So yes, a tick. Now, is the coefficient of x squared, is that negative or positive? So I'm just going to quickly expand this. This will become y equals x squared plus 2x, so not 2x, 1x plus 3x plus 3, and so this ends up being y equals x squared plus 4x plus 3. So if you can see the sign in front of the x squared, the sign in front of the x squared is positive, therefore we have a, for question 2, we have a positive parabola. And the positive parabola will look like that. Now we need to find the turning points, so this is step 3. If we want to find the turning points, we let, so not turning points, if we want to find the intercepts, we let y equals 0. So if we let y equals 0, what happens is that this becomes 0 equals x plus 1 brackets x plus 3. And from here we need to implement the null factor law, which means that we need to see where does this brackets equal 0 and where does this brackets equal 0. Or if we write it out, where does x plus 1 equal 0, or where does x plus 3 equal 0. So if that's the case, x plus 1 equals 0 when x equals minus 1, and this one equals 0 when x equals minus 3. So therefore our coordinates will be minus 1, 0, and this one will be minus 3 and 0. So that's step 3 done. Now we just need to find where the turning point is. So let's do part 4. Part 4. My screen has gone crazy. Okay. Part 4. So I'm going to draw part 4 right here. So to get the turning point, so turning point is equal to minus b on 2a. For this equation, we need to refer back to the expanded form. What is the a value? The a value is equal to 1, the b value is equal to 4, and the c value is equal to 3. So we just need minus b on 2a. So minus b, the turning point, will be minus 4 on 2 times 1. And so the turning point will be 4 minus 4 on 2, which is minus 2. Now keep in mind that when we're finding the turning point, this is only the x coordinate. So what I mean by that is that this thing right here is only one part of the turning point. We still don't know what that other turning point is. We know that the x part of it is at minus 2. But we still need to substitute this back into the equation so that we can work out what the y coordinate is for this. So we're going to just move this down a bit. So this will end up becoming, well, we have to refer back to our original equation. And our original equation is y equals x squared plus 4x plus 3. So we know the turning point is when x equals minus 2, so sub x equals minus 2 into there. And so if we sub x equals minus 2, we get y equals minus 2 squared plus 4 times minus 2 plus 3. And so from here, this ends up becoming y is equal to 4 minus 8 plus 3. Sorry, that number should be a 3 back there. 3. And this ends up becoming y is equal to 4 minus 8 is minus 4 plus 3 is minus 1. So therefore, our turning point is at minus 2 minus 1. So you can see we can already draw the graph because we have a graph that looks like this. We've got two intercepts, so one at minus 1. So I'm going to draw an x at minus 1. We've got an x at minus 3. Actually, you know what, guys? So I'm just going to enlarge this graph just because the scaling is a bit out of proportion in this case. So I'm going to enlarge it just so it makes a bit more. I'm going to delete that. So the first point is at minus 1, 0. So minus 1, 0 is right here. The other point is at minus 3, 0. I'm going to draw it right there. And the last point that we worked at, the turning point, was at minus 2, minus 1. Minus 2, minus 1 is here. So we already have 3 points that we can use to draw this parabola. The step that says optional, state the y-intercept if there are no x-intercepts, well, we can draw the graph now. However, if you do want to include the y-intercept, you just need to look at this last number right here. So the y-intercept is, so y-intercept is at 0, 3. So since the y-intercept is at 0, 3, I can draw another dot or an x at 0, 3. And this will become a lot more, hopefully a lot more accurate. So let's draw it from here. This is terrible. There. And so that's a rough sketch of what the graph would look like. Now, again, let's have a look at the domain. The domain of this graph, you can be anywhere from negative infinity to infinity. and we can have a look at range. So what are the possible values going from bottom to top? Well, it hits at -1, so that means it can equal -1. But what is the maximum value that it can have? If we enlarge it, it can be infinity. So that concludes that example.